More than 500 million years ago, Antarctica looked nothing like the endless land of ice we know today. Long before it became the coldest place on Earth, it was home to thick forests, flowing rivers, giant reptiles, early dinosaurs, and many strange plants and animals. Warm seasons lasted for months, and life continued to grow even through long periods of darkness. As the continent slowly moved and the planet's climate changed over millions of years, this rich environment gradually became a frozen land covered by massive sheets of ice. Beneath that ice are rocks and fossils that provide important evidence about Antarctica's ancient past. Antarctica is known today as the coldest place on Earth. It is covered by a massive sheet of ice that hides almost all of its land. Powerful winds sweep across its frozen surface, and temperatures often fall far below freezing for much of the year. Most people think of Antarctica as a place that has always been frozen. However, scientific discoveries show that this was not always true. Long before thick ice covered the continent, Antarctica was a land filled with forests, rivers, lakes, wetlands, and many forms of life. It had a much warmer climate, and plants and animals lived there for millions of years. The frozen land that exists today was once a green continent, with changing seasons, flowing water, and rich natural environments. The story of ancient Antarctica stretches back hundreds of millions of years. During much of Earth's early history, the continents were arranged very differently from the way they appear today. Antarctica was not isolated at the bottom of the world. Instead, it formed part of a huge southern landmass called Gondwana. This giant continent included the lands that are now Africa, South America, Australia, India, Madagascar, the Arabian Peninsula, and Antarctica. These lands were joined together for a very long time before they slowly drifted apart because of the movement of Earth's tectonic plates. While Antarctica was part of Gondwana, it shared plants, animals, rivers, and mountain systems with the other connected lands. Many species were able to spread across large areas because there were no oceans separating these regions. Fossils found today in Antarctica closely match fossils discovered in South America, Africa, India, and Australia. These discoveries provide strong evidence that the continents were once connected and supported similar living things. The climate of Antarctica during those distant times was very different from today's climate. Much of the continent enjoyed mild temperatures for long periods. Rain fell regularly in many places, feeding rivers and lakes that supported large forests. The land contained rich soils where many kinds of plants could grow. Although Antarctica was located farther south than many other parts of Gondwana, Earth's climate during several ancient periods was much warmer than it is today. There were no permanent ice sheets covering the continent. Ancient forests spread across large parts of Antarctica. Many trees grew well in the warm and moist conditions. These forests included early relatives of modern conifers, seed ferns, ginkgo relatives, and many other kinds of plants that no longer exist. The forests were dense in some areas, while other regions contained open woodlands and wetlands. Mosses, ferns, horsetails, and small shrubs covered the ground beneath the taller trees. The forests changed as Earth's climate changed over millions of years. Different plant groups became more common at different times. Some species disappeared while new ones appeared. Fossil leaves, branches, pollen grains, seeds, and pieces of wood preserved in Antarctic rocks allow scientists to study these ancient forests in great detail. Some fossil trees still show growth rings, much like modern trees. These rings record yearly changes in growing conditions and provide valuable information about ancient climates. Although Antarctica experienced long periods of daylight during summer and long periods of darkness during winter, because of its southern location, many plants adapted successfully to these seasonal changes. The long summer days provided many hours of sunlight, allowing plants to grow rapidly during the warmer months. During the darker winter months, many plants slowed their growth until sunlight returned. This yearly pattern continued for countless generations. Large river systems crossed ancient Antarctica. Rainwater collected in streams that joined together to form rivers flowing across wide valleys. These rivers carried sand, mud, and small stones from higher ground into lower areas where they formed floodplains. Floodplains provided rich soils that supported thick plant growth. Rivers also supplied fresh water for animals living nearby. Many lakes formed throughout the continent. Some lakes were small and shallow, while others were much larger and deeper. These lakes became home to many forms of aquatic life. Small fish swam through their waters, while insects lived along the shorelines. Plants grew in and around the lakes, creating habitats for many living creatures. Layers of mud slowly settled on lake bottoms, preserving remains of plants and animals that later became fossils. Wetlands covered large areas of ancient Antarctica. Swamps and marshes formed wherever water remained for long periods. These wet places supported thick plant growth and many kinds of animals. Fallen trees, leaves and other plant material collected in waterlogged ground where they broke down slowly because little oxygen reached them. Over millions of years, some of this plant material became coal. Coal deposits discovered in Antarctica provide clear evidence that large forests once covered parts of the continent. The discovery of coal surprised early explorers because coal forms mainly from the remains of thick vegetation growing in warm and wet environments. The presence of coal beneath Antarctica's ice shows that forests existed there long before the continent became frozen. Scientists have found coal layers in several parts of Antarctica, adding to the growing evidence of its warmer past. Many kinds of insects lived among Antarctica's ancient plants. Fossils show that insects played important roles in these ecosystems. They fed on leaves, helped break down dead plant material, and served as food for larger animals. Some insects probably pollinated certain plants, although many early plants reproduced through spores or wind-carried pollen, rather than insect pollination. Spiders and other small land animals also lived in these forests. Their remains are rarely preserved because their bodies were delicate, but scientists have found enough evidence to show that they formed part of the ancient ecosystems. Small creatures living in soil and leaf litter helped recycle nutrients by breaking down dead organic matter. Freshwater fish lived in rivers and lakes throughout the continent. Fossil fish provide information about ancient water conditions and help scientists understand how freshwater ecosystems developed. Some fish species were related to forms found elsewhere in Gondwana, reflecting the close connection between these lands before they separated. Amphibians lived near rivers, lakes, and wetlands. They depended on water for reproduction and spent much of their lives in moist environments. Ancient amphibians varied greatly in size and appearance. Some resembled modern salamanders, while others had broad heads and powerful bodies suited for life near water. Their fossils helped scientists understand the changing environments of ancient Antarctica. Reptiles gradually became important members of Antarctica's ecosystems. Early reptiles adapted well to life on land because they laid eggs that did not require water in the same way amphibian eggs did. This allowed reptiles to spread into a wider variety of habitats. Over millions of years, reptiles became more diverse and occupied many different ecological roles. During the age of dinosaurs, Antarctica supported many remarkable animals. At that time, the continent remained much warmer than it is today, although seasonal darkness continued because of its southern location. Dinosaurs successfully adapted to these conditions and lived there for millions of years. Plant-eating dinosaurs moved through forests and open landscapes, searching for leaves, branches, and other vegetation. Some traveled in groups, while others may have lived more independently. Fossil bones found in Antarctica show that several kinds of herbivorous dinosaurs lived on the continent during different periods. Meat-eating dinosaurs also lived in Antarctica. These animals hunted other dinosaurs and smaller creatures. Fossils suggest that some Antarctic predators belong to groups found elsewhere in Gondwana. Their presence shows that Antarctica supported complete ecosystems with both plant-eaters and hunters. Scientists continue to discover new dinosaur fossils beneath Antarctic rock layers exposed along mountain ranges and coastal areas. Each discovery adds new information about the animals that once lived there. Because much of Antarctica remains hidden beneath thick ice, many fossils likely remain buried and undiscovered. Flying reptiles passed over ancient Antarctica during some periods of Earth's history. These animals searched for food near rivers, lakes, and coastlines. Their lightweight bones rarely became fossils, making discoveries uncommon. Even so, evidence suggests that flying reptiles formed part of the continent's ancient wildlife. Small mammals also appeared during the age of dinosaurs. These early mammals lived quietly alongside much larger reptiles. Most were probably active during different times of day from many dinosaurs. They fed on insects, seeds, fruits, and other available food sources. Fossil teeth and small bones provide evidence of their presence in ancient Antarctica. Bird ancestors gradually became more common as time passed. Some early birds possessed both ancient and modern features. They lived in forests, searched for food among trees, and sometimes nested on the ground or in branches. Their fossils help scientists understand the early development of birds in southern environments. The plants of ancient Antarctica became increasingly diverse through time. Flowering plants eventually spread across many regions of the continent. These plants produced flowers and seeds enclosed within fruits. Flowering plants attracted insects and other animals that helped spread pollen and seeds. Their arrival changed the appearance of many ancient landscapes. Different environments existed across Antarctica. Some regions contained thick forests with tall trees reaching toward the sky. Other areas supported lower vegetation, shrubs, and open woodlands. River valleys often contained especially rich plant growth because water and nutrients remained plentiful. Higher ground supported different plant communities suited to local conditions. Volcanic activity also influenced parts of Antarctica throughout its long history. Volcanoes erupted during various periods, covering surrounding land with lava and ash. Fresh volcanic rock slowly broke down into fertile soil that supported new plant growth. Volcanic ash sometimes buried forests quickly, helping preserve leaves, branches, and tree trunks as fossils. Earthquakes occasionally shook the continent as tectonic plates continued moving. Mountain ranges slowly rose while other areas sank. Rivers changed course, new valleys formed, and lakes appeared or disappeared as the landscape evolved over millions of years. These geological changes influenced where plants and animals could live. The movement of tectonic plates slowly carried Antarctica toward its present position around the South Pole. This movement happened extremely slowly, far too slowly for any person to notice, but over millions of years it changed the continent's location enough to affect its climate. As Antarctica drifted farther south, temperatures gradually became cooler. At the same time, Gondwana itself began to break apart. As Antarctica drifted farther south, temperatures gradually became cooler. At the same time, Gondwana itself began to break apart. Large cracks developed within the giant continent as tectonic forces pulled the land in different directions. South America, Africa, India, Australia, and Antarctica slowly separated from one another. Oceans gradually formed between these drifting continents. As the oceans widened, the movement of water around Antarctica also changed. These changing ocean patterns became increasingly important in shaping Antarctica's climate. Ocean currents carried heat around the planet. As Antarctica became more isolated, cold water began circulating around the continent more freely. This reduced the amount of warm water reaching Antarctic shores. Over long periods, the climate continued becoming cooler, setting the stage for even greater environmental changes that unfolded across the continent. The ancient supercontinent of Gondwana was one of the largest landmasses that ever existed on Earth. It played a major role in the history of the planet and shaped many of the continents that exist today. Antarctica was an important part of Gondwana for a very long time. The frozen continent that people know today was once located in a very different environment. It was joined to several other continents, shared plants and animals with them, and experienced climates that changed over millions of years. Understanding Gondwana helps explain why Antarctica contains rocks, fossils, mountain ranges, and other natural features that connect it with continents that are now separated by vast oceans. The story of Gondwana began after Earth had already formed and after the planet's surface had cooled enough for a solid crust to develop. The crust was never completely still. Deep inside Earth, heat caused slow movement in the rocky material beneath the crust. This movement slowly pushed large pieces of the crust, called tectonic plates, across the surface of the planet. These movements were extremely slow, often only a few centimeters each year, but over millions of years they changed the positions of entire continents. During Earth's early history, continents repeatedly joined together and later separated. Gondwana was one of these great land masses. Scientists believe that it began forming during the late Precambrian, around 600 million years ago. Smaller pieces of land gradually collided because of plate movement. These collisions created mountain ranges, changed coastlines, and joined separate blocks of land into one enormous continent. Gondwana eventually included what are now Antarctica, Africa, South America, Australia, the Indian subcontinent, Madagascar, the Arabian Peninsula, and several smaller land areas. Although these regions are now separated by oceans, they were once connected as parts of one continuous landmass. This connection lasted for hundreds of millions of years and left many clues that scientists continue to study today. Antarctica occupied an important position within Gondwana. It was not a distant piece at the edge of the continent, but instead formed a central part of this enormous landmass. Different regions of Antarctica touched different neighbouring lands. Eastern Antarctica was connected to Australia and India, while other parts were linked with Africa and South America. Because of these connections, plants and animals could spread across large areas without needing to cross oceans. The rocks of Antarctica provide some of the strongest evidence that it was once part of Gondwana. Geologists have found rock layers that match those found in southern Africa, Australia, India, and South America. These rocks often have similar ages, similar minerals, and similar structures. Mountain belts also continue from one continent to another, when the continents are placed back together in their ancient positions. These matching features show that the continents were once joined before they drifted apart. Scientists study these rocks carefully because they preserve information about ancient environments. Some rocks formed deep beneath the surface during volcanic activity. Others formed in rivers, lakes, deserts, or shallow seas. By examining the minerals, textures, and chemical makeup of these rocks, researchers can learn about the conditions that existed when they were created. Antarctica contains many different rock types that record a long history of changing environments while it was still part of Gondwana. Fossils provide another important source of evidence. Many fossil plants and animals found in Antarctica are closely related to fossils discovered on other southern continents. One of the best-known examples is the seed fern called Glossopteris. This plant grew widely across Gondwana and left fossil leaves in Antarctica, Africa, South America, India, Australia, and other regions. Because Glossopteris seeds were too large and heavy to travel across wide oceans, scientists concluded that these lands had once been connected. Glossopteris forests covered large areas of Gondwana for millions of years. These plants were well suited to the climates that existed during much of that time. Their leaves fell to the ground, became buried in mud and sand, and were eventually preserved as fossils. In some places, large amounts of plant material were buried and later changed into coal. Coal deposits found across several southern continents show that thick forests once grew in areas that are now widely separated. Antarctica also contains fossils of ancient trees that grew in warmer conditions than those found there today. Fossil wood, leaves, pollen, and roots reveal that forests once covered parts of the continent. These forests experienced long periods of daylight during summer and long periods of darkness during winter, because Antarctica was already located at high southern latitudes during much of its history. Even so, temperatures were much milder than they are today, allowing many kinds of plants to survive. Scientists have discovered fossil pollen trapped inside rocks from Antarctica. Pollen grains are extremely small but have tough outer walls that can survive for millions of years. By identifying these pollen grains, researchers can determine which plants once lived in ancient forests. Different kinds of pollen also help scientists estimate the climate that existed when those plants were growing. Animal fossils strengthen the evidence for Gondwana. Fossils of reptiles, amphibians, and early mammals have been found across several former Gondwanan continents. One famous example is Lystrosaurus. Fossils of this animal have been discovered in Antarctica, Africa, and India. Lystrosaurus was a plant-eating animal that lived after Earth's largest known mass extinction. Its fossils suggest that these continents remained connected during its lifetime, allowing animals to move across the land. Another important fossil animal is Mesosaurus. Although its fossils have been found mainly in South America and Africa rather than Antarctica, they provide powerful evidence that Gondwana existed. Mesosaurus lived in freshwater environments. It could not have crossed a wide ocean, yet its fossils appear on continents now separated by the Atlantic Ocean. This distribution supports the idea that these continents were once joined. The climate of Gondwana changed many times throughout its long history. During some periods, large ice sheets spread across parts of the continent. During other periods, forests expanded into regions that are now covered by ice. Antarctica preserves evidence of both freezing and warmer climates. Rocks scratched by moving glaciers show that thick ice once flowed across parts of Gondwana during the late Paleozoic era. These scratches, called glacial striations, point in directions that make sense only when the southern continents are placed back together. large boulders carried by glaciers were left behind as the ice melted. These rocks often came from distant places and were transported by moving ice over great distances. Similar glacial deposits appear across Antarctica, Africa, South America, India, and Australia. Their matching ages and characteristics provide another line of evidence that these continents experienced the same ice age while they were connected. The glaciers eventually retreated as Earth's climate became warmer. Forests spread again across Gondwana, and many kinds of plants flourished. Rivers carried sediments across broad plains, creating layers of sandstone, mudstone, and shale that remain visible today. Fossils preserved within these rocks tell scientists about the plants and animals that lived during those times. As Gondwana continued to exist, volcanic activity remained common in some regions. Volcanoes erupted as tectonic forces affected the continent. Lava cooled into hard rock while volcanic ash settled over surrounding landscapes. Some ash layers later became valuable to scientists because they contain minerals that can be dated using radioactive elements. These dates help researchers place fossils and geological events into the correct order. Mountain building also shaped Gondwana. Whenever pieces of crust collided, rocks were pushed upward and folded into mountain ranges. Deep underground, heat and pressure changed existing rocks into metamorphic rocks. Granite formed when molten rock cooled beneath the surface. Antarctica contains large areas of metamorphic and igneous rocks that formed during these ancient mountain-building events. The interior of Gondwana supported many rivers and lakes. Water flowing across the land carried sand, mud, and small stones into low areas, where thick layers of sediment accumulated. Over long periods, these sediments hardened into sedimentary rocks. Today, these rocks preserve ripple marks, mud cracks, footprints, burrows, and other signs of ancient environments. The position of Antarctica within Gondwana affected weather patterns and ocean circulation. Because the continents were joined together, coastlines differed greatly from those of today. Ocean currents followed different paths, influencing temperatures and rainfall. Winds also moved differently because the arrangement of land and sea was unlike the modern world. These factors influenced where forests, deserts, wetlands and rivers developed across Gondwana. Life continued to evolve while Gondwana remained intact. Early reptiles became more diverse, amphibians occupied rivers and wetlands, insects spread through forests, and many plant groups adapted to changing climates. Antarctica shared in these biological changes because it remained connected to neighboring regions for a very long time. Plants and animals could expand their ranges across the supercontinent without facing large ocean barriers. During the age of dinosaurs, Gondwana remained one of Earth's dominant landmasses. Dinosaurs lived across Antarctica as well as on the other southern continents. Fossils found in Antarctica include the remains of meat-eating and plant-eating dinosaurs. Although fossil discoveries are difficult, because most of the continent is buried beneath thick ice, each new discovery adds valuable information about the animals that once lived there. The climate during much of the dinosaur age was warmer than it is today. Antarctica did not have the enormous ice sheets that now cover almost the entire continent. Forests containing conifers, ferns, cycads and other plants grew across many areas. Dinosaurs fed among these plants and raised their young despite the long periods of winter darkness that occurred each year. Researchers continue to uncover new evidence from exposed rock formations in Antarctica. During the short summer field season, scientists travel to remote mountain ranges where ancient rocks are visible above the ice. They carefully collect fossils, rock samples and other evidence before returning to laboratories for detailed study. Each discovery helps improve understanding of Gondwana and Antarctica's long geological history. Plate tectonic movement eventually began to break Gondwana apart. Deep cracks developed within the continent as forces beneath Earth's surface stretched the crust. Molten rock rose into these cracks, creating new oceanic crust as the land slowly separated. This process happened over many millions of years rather than all at once. The first major separations began during the Jurassic period. Different parts of Gondwana gradually drifted away from one another. Africa and South America eventually separated as the South Atlantic Ocean opened. India later moved northward on its own tectonic plate. Australia remained connected to Antarctica much longer before finally separating. Each stage of this breakup changed the shape of Earth's continents and oceans, creating the world that exists today. The Antarctica of the distant past was located in a different position on Earth than it is today. The movement of Earth's continents is very slow, but over many millions of years, it changes the shape and position of the land. Antarctica was once joined with other southern continents as part of the ancient supercontinent called Gondwana. This huge landmass included what are now South America, Africa, Australia, the Indian subcontinent, and Antarctica. Since these lands were connected, plants and animals could spread from one region to another without crossing wide oceans. Seeds could travel across forests, rivers, and open land, allowing many kinds of plants to become established across the supercontinent. During much of this time, the climate was much warmer than it is today. Earth passed through long periods when global temperatures remained high. There were no large permanent ice sheets covering Antarctica. Rain fell regularly across much of the continent. Rivers carried fresh water through valleys, and lakes formed in low areas. The ground remained moist in many places, creating excellent conditions for plant growth. Rich soils slowly formed as leaves, branches, roots, and other plant material broke down over long periods. These soils stored nutrients that supported even more plant life. The atmosphere during many ancient periods also helped plants grow well. Carbon dioxide levels were often much higher than they are today. Carbon dioxide is one of the gases that plants use during photosynthesis to make food from sunlight and water. Higher levels of this gas allowed many plants to grow more quickly under suitable conditions. Warm temperatures and abundant rainfall created environments where forests could spread over wide regions. Plants captured sunlight during the growing season and stored energy that supported continued growth. Even though Antarctica experienced long periods of daylight and darkness, because of its position on Earth, ancient plants found ways to survive these changing seasons. During the summer months, the sun stayed above the horizon for long periods, providing many hours of light every day. Plants took advantage of this continuous sunlight by growing rapidly. They produced large numbers of leaves, expanded their branches, and built strong root systems. During the darker winter months, growth slowed. Many trees shed their leaves before winter arrived, reducing water loss and saving energy until sunlight returned. Other plants remained green but entered a resting period until better growing conditions came back. Scientists have learned about Antarctica's ancient forests by studying fossils. Fossils are the preserved remains or traces of ancient living things. They include pieces of wood, leaves, pollen, seeds, roots, tree trunks, spores, and even entire forests buried beneath layers of rock. These fossils provide valuable information about the plants that once covered the continent. Careful examination allows scientists to identify many species and understand the environments in which they lived. Fossil leaves are especially useful because different plants have leaves with different shapes, sizes, and patterns of veins. Some leaves have smooth edges while others have small teeth along their margins. Some are long and narrow while others are broad and rounded. These features help scientists identify ancient plant groups even when the rest of the plant is missing. Fossil leaves also provide clues about ancient climates because different leaf shapes often grow under different environmental conditions. Ancient wood preserved inside Antarctic rocks also tells an important story. Some fossilized tree trunks still contain growth rings. These rings formed as trees grew each year. Wide rings usually show periods of faster growth under favorable conditions, while narrower rings often indicate slower growth. By counting and studying these rings, scientists can learn how long individual trees lived and how growing conditions changed over time. The rings also show that many Antarctic trees experienced regular, seasonal changes, rather than growing at the same rate throughout the entire year. Pollen grains are another important source of information. These tiny structures are produced by seed plants during reproduction. Pollen has a tough outer coating that can survive for millions of years after being buried in sediments. Scientists collect samples from ancient rocks and examine the pollen under powerful microscopes. Different plant species produce pollen with unique shapes and surface patterns. By identifying fossil pollen, researchers can determine which plants lived in an area even when larger fossils are absent. Spores also help scientists understand ancient plant life. Ferns, mosses, and several other plants reproduce using spores instead of seeds. Like pollen, spores can survive for very long periods after burial. Fossil spores found in Antarctic rocks show that many kinds of smaller plants grew beneath the forest canopy. These plants covered the ground, helped hold the soil together, and added organic material as they died and decomposed. Large forests once covered broad parts of Antarctica during several geological periods. Among the most important trees were members of an ancient group called glossopterids. These seed-bearing plants became some of the most successful plants across Gondwana. Their leaves were broad with clear patterns of veins running through them. Fossils of glossopterid leaves have been found across Antarctica, as well as in South America, Africa, Australia, and the Indian subcontinent. Their widespread distribution provided important evidence that these continents were once joined together. Glossopterid forests form dense woodlands across large areas. Their roots spread through the soil, helping stabilize the land and reduce erosion. Their leaves fell to the ground each year, creating thick layers of plant material that slowly broke down into rich soil. These forests supported many other forms of life. Smaller plants grew beneath their branches, while insects fed on leaves, stems, and wood. Rivers flowing through these forests carried fallen branches and leaves into lakes and swamps, where many became buried and eventually fossilized. Ancient conifer trees also became important members of Antarctic forests. These trees belong to groups that were related to modern conifers, although many ancient species no longer exist today. Some had needle-like leaves, while others had broader foliage. Their wood formed strong trunks that allowed them to reach great heights. Many produced cones that contained seeds. These seeds could be carried by wind or water, helping new forests spread across suitable habitats. Tree ferns also played a major role in Antarctic forests. Unlike the small ferns commonly seen today, some ancient tree ferns grew tall enough to become part of the forest canopy. Their large fronds collected sunlight and produced food through photosynthesis. Smaller ferns covered the forest floor, creating thick green layers beneath taller trees. Ferns thrived in moist conditions, making river valleys, wetlands, and swampy areas especially suitable for their growth. Cycads also lived across ancient Antarctica. These seed plants had thick trunks topped by crowns of stiff leaves. Although they looked somewhat like palm trees, they belonged to a completely different plant group. Cycads reproduced using cones and often grew in warm environments with abundant sunlight. Fossils show that they were common members of many ancient ecosystems throughout Gondwana. Another group called ginkgophytes also lived in Antarctica. These trees had distinctive fan-shaped leaves that are easy to recognize in fossil form. Today only a single living species remains, but many different kinds existed in the distant past. Their fossils show that they successfully adapted to the changing seasons of ancient Antarctica. They shed their leaves before winter and produced fresh leaves when warmer weather returned. Horsetails also formed part of many plant communities. These plants had hollow stems divided into clear sections. Some ancient species reached much larger sizes than most living horsetails. They often grew along riverbanks, lake edges and wetlands, where water remained available throughout the year. Their underground stems helped them spread across moist ground, forming dense patches that stabilized the soil. Mosses and liverworts covered damp surfaces beneath larger plants. Although they were small, they played important roles in the ecosystem. They trapped moisture, slowed soil erosion, and provided places for tiny animals to live. These simple plants also helped begin soil formation on newly exposed surfaces by trapping dust and organic material. Flowering plants eventually appeared during later geological periods and gradually spread into Antarctic forests. These plants developed flowers that attracted insects and other pollinating animals. After successful pollination, they produced seeds enclosed within fruits. Flowering plants added even greater diversity to Antarctic ecosystems as they expanded across suitable environments. Wetlands became some of the richest habitats for plant growth. Water remained available throughout much of the year, allowing many plant species to thrive. Thick layers of vegetation covered the edges of lakes and rivers. Dead plant material accumulated in these wet places faster than it completely decomposed. Over long periods, these thick deposits of organic matter became buried beneath sediments. Under pressure and heat over millions of years, some eventually changed into coal. Coal deposits found in Antarctica provide strong evidence that thick forests once existed there. Coal forms mainly from the remains of large amounts of plant material buried in wet environments. The discovery of coal beneath Antarctic rocks surprised early explorers because such deposits could only have formed where abundant vegetation once grew. These coal layers preserve the record of forests that covered the continent long before the arrival of permanent ice. Ancient rivers carried water from higher ground into valleys and low plains. Along their banks, plants found steady supplies of moisture and nutrients. Trees grew close together, while shrubs, ferns, and mosses filled the spaces between them. Seasonal floods spread fresh sediments across the floodplains, adding minerals that supported continued plant growth. These river systems also carried seeds and fallen branches to new locations where plants could become established. Lakes provided another important environment for rich plant life. Their shores supported dense vegetation that benefited from moist soils. Leaves, pollen, spores, and branches often fell into the water, where mud quickly buried them. Because of this rapid burial, many delicate plant remains survived as fossils. Today, these lake deposits help scientists reconstruct ancient Antarctic ecosystems with remarkable detail. Swamps formed wherever water collected and drained very slowly. Thick vegetation filled these wet landscapes. Fallen leaves and wood accumulated year after year, creating deep layers of organic material. Since oxygen levels inside waterlogged soils remained low, decomposition happened slowly. This allowed large amounts of plant matter to build up over long periods, eventually contributing to coal formation after burial beneath sediments. The soils that supported Antarctic forests developed gradually through natural processes. Rocks slowly broke apart because of weathering caused by rain, flowing water, changing temperatures, and chemical reactions. Tiny organisms, fungi, and plant roots also helped break down rocks into smaller particles. As dead plants decomposed, they mixed with mineral particles to create fertile soils rich in nutrients. These soils stored water and provided strong support for expanding root systems. Fungi played an important role beneath the surface. Many fungi formed close partnerships with plant roots. Fine fungal threads spread through the soil and helped collect water and minerals that plants needed for healthy growth. In return, plants supplied the fungi with sugars produced during photosynthesis. These relationships increased the ability of forests to thrive across different environments. Tiny bacteria living in the soil also helped recycle nutrients. They broke down dead leaves, wood, and other plant remains into simpler materials that could be absorbed again by growing plants. Without these microscopic organisms, nutrients would remain locked inside dead material, instead of returning to the soil where new plants could use them. Insects were closely connected with Antarctic forests. Many fed directly on leaves, stems, wood, pollen, or seeds. Others helped pollinate plants or break down dead organic matter. Fossil evidence shows that insects interacted with plants in many different ways. Some fossil leaves even contain small holes and feeding marks left by ancient insects, while the plants were still alive. During much of the age of dinosaurs, Antarctica was part of the giant southern supercontinent known as Gondwana. It was connected to South America, Africa, Australia, India, and Madagascar. Animals could move across these connected lands without crossing large oceans. This allowed many dinosaur groups to spread over great distances and settle into different environments. Antarctica occupied a southern position on Earth, but the planet's climate was much warmer because of higher levels of greenhouse gases in the atmosphere and different patterns of ocean circulation. Even though Antarctica experienced long periods of darkness during winter because of its location near the South Pole, temperatures remained mild enough for forests and many animals to survive. The dinosaurs that lived in Antarctica had to deal with unusual seasonal conditions. During summer, the sun stayed above the horizon for long periods, providing many hours of daylight for plants to grow quickly. During winter, darkness lasted for many weeks, although the temperatures were far warmer than today's freezing conditions. Scientists believe that many plants slowed their growth during these darker months while remaining alive until sunlight returned. The animals living there had to find ways to survive these yearly changes. Some may have remained active throughout the year, while others may have reduced their activity during the darkest months. Evidence continues to be studied as researchers search for clues preserved in ancient rocks. One of the best-known dinosaurs discovered in Antarctica is Cryolophosaurus. Its name means frozen crested lizard because its fossils were found in Antarctica, and because it had a distinctive crest on the top of its head. Cryolophosaurus lived during the early Jurassic period. Around 190 million years ago, it was one of the largest meat-eating dinosaurs of its time. Scientists estimate that it reached about 20 to 25 feet in length and stood several feet tall at the hips. It walked on two strong legs, had powerful jaws filled with sharp teeth, and used its long tail to help maintain balance while moving. The crest on the head of Cryolophosaurus was unlike that of many other meat-eating dinosaurs. It stretched across the top of the skull from one side to the other. Scientists believe that this crest may have been used for display, helping individuals recognize members of their own species or attract mates. Since the crest was thin, it was probably not strong enough to be used during fights. The skull also contained openings that reduced its weight while still providing enough strength for biting into prey. Cryolophosaurus probably hunted many kinds of animals that lived in Antarctica's forests and open spaces. Smaller reptiles, early mammals, and plant-eating dinosaurs may have been part of its diet. It may also have fed on animals that had already died when the opportunity arose. Like many meat-eating dinosaurs, it likely depended on its sharp eyesight, powerful legs, and strong sense of smell while searching for food. Fossils show that it possessed the body structure expected of an active predator, capable of moving quickly across uneven ground. Another important dinosaur discovered in Antarctica is Glacialisaurus. This plant-eating dinosaur lived during the early Jurassic period. It belonged to a group known as sauropodomorphs, which included the ancestors of the enormous long-necked dinosaurs that later became some of the largest land animals in Earth's history. Glacialisaurus had a long neck, a relatively small head, and a body designed for feeding on leaves, shoots, and other plant material growing throughout Antarctic forests. The bones of Glacialisaurus show that it was much larger than many earlier plant-eating dinosaurs. It probably walked on both 2 and 4 legs, depending on its activity and age. Its long neck allowed it to reach leaves growing at different heights without moving its whole body very often. Strong limbs supported its weight, while broad feet helped it move across soft ground near rivers and wetlands. Fossil discoveries suggest that large plant-eating dinosaurs had already become important members of Antarctic ecosystems during this time. Another remarkable dinosaur from Antarctica is Antarctopelta. Unlike many earlier discoveries, Antarctopelta lived during the late Cretaceous period, around 70 million years ago. By then, Antarctica had already begun to experience cooler conditions than before, although it was still much warmer than it is today. Antarctopelta belonged to a group of armored dinosaurs called ankylosaurs. Its body was covered with thick, bony plates that formed natural protection against predators. Sharp spikes projected from different parts of its body, making attacks even more difficult. Antarctopelta moved on 4 sturdy legs and spent much of its time feeding on low-growing plants. Its small head contained teeth suited for cutting vegetation rather than chewing it thoroughly. Like many plant-eating dinosaurs, it probably swallowed stones that remained inside its stomach to help grind food during digestion. Fossil remains indicate that this dinosaur survived in southern forests filled with flowering plants, conifers, ferns, and many other forms of vegetation. Scientists have also discovered fossils belonging to another armored dinosaur called Kunbarasaurus in Australia, along with Antarctopelta in Antarctica, helping researchers understand that armored dinosaurs were spread across Gondwana. These discoveries show that connected southern continents allowed many dinosaur groups to spread into different regions while developing their own unique features over time. Plant-eating dinosaurs were important because they formed a major part of the food supply for large predators. Their feeding helped shape forests by affecting which plants grew most successfully. As they moved through the landscape, they may have spread seeds and disturbed the soil, creating new places where young plants could grow. Their activities became part of the natural balance within Antarctic ecosystems. Scientists have found evidence that small meat-eating dinosaurs also lived in Antarctica, although many of their fossils remain incomplete. Some isolated bones and teeth suggest that several species of theropods hunted across the forests. These smaller predators probably fed on reptiles, insects, early mammals, amphibians, and young dinosaurs. Their lighter bodies allowed them to move through dense vegetation while searching for prey. The fossil record in Antarctica remains incomplete because most of the continent is buried beneath thick ice sheets. Only a small portion of ancient rocks is exposed where scientists can search for fossils. Many discoveries come from mountain ranges where wind, glaciers, and natural erosion have uncovered layers of rock that formed during the age of dinosaurs. Reaching these locations requires careful planning, because weather conditions can change rapidly, even during the Antarctic summer. Field teams often travel by aircraft or ship before continuing by helicopter or snow vehicle to fossil sites. Researchers must carry equipment, food, shelter, fuel, and scientific supplies because these areas are far from permanent settlements. Excavating fossils requires patience since bones are usually buried inside very hard rock. Scientists carefully remove surrounding stone using small tools so that delicate fossils are not damaged. Each bone is mapped, photographed, and protected with special coverings before being transported to research laboratories. Once fossils arrive at laboratories, technicians spend many months removing the remaining rock with fine tools under microscopes. Every bone is carefully studied to identify its shape, age, and possible relationship to other dinosaurs. Scientists compare Antarctic fossils with discoveries from South America, Australia, Africa, India, and other continents that were once connected within Gondwana. These studies help researchers understand how dinosaur populations spread and changed through millions of years. Dinosaurs were not the only reptiles living in Antarctica. Crocodile relatives also inhabited rivers, lakes, and wetlands where fish and other aquatic animals were plentiful. These reptiles occupied freshwater habitats and probably fed on fish, amphibians, and small land animals that approached the water. Fossils show that ancient crocodile relatives lived much farther south than their modern descendants because the climate was warm enough to support them. Flying reptiles known as pterosaurs also existed during much of the dinosaur age, although their fossils are extremely rare in Antarctica. Their lightweight bones were less likely to survive the fossilization process, making discoveries uncommon. Scientists believe that some species flew over Antarctic forests and coastlines searching for fish, insects, and other small animals. Their presence would have added another group of reptiles to the diverse wildlife living across the continent. Marine reptiles lived in the seas surrounding Antarctica as well. Long-necked plesiosaurs swam through coastal waters, hunting fish and squid-like animals. Other marine reptiles with shorter necks and stronger jaws searched for larger prey. These animals were not dinosaurs, but they shared the same ancient world and formed an important part of Antarctic life. Fossils recovered from marine rocks show that the nearby seas supported rich ecosystems filled with many kinds of swimming reptiles, fish, shellfish, and other ocean life. Early turtles also lived in Antarctic waters and freshwater environments. Their shells provided protection, while they fed on plants, small animals, or both depending on the species. Fossils indicate that turtles adapted successfully to different habitats across Gondwana and survived many environmental changes over long periods of Earth's history. Marine reptiles were among the most successful animals that lived in the ancient seas during the time of the dinosaurs. While giant dinosaurs walked across the land, many different reptiles ruled the oceans. The waters around the southern continent were full of life for millions of years. Long before Antarctica became covered with thick ice, it was surrounded by seas that supported many kinds of living things. The climate was much warmer than it is today, and the oceans contained fish, shellfish, squid-like animals, corals, sea plants, and countless smaller creatures that formed rich food chains. These conditions allowed marine reptiles to spread into the waters around the southern continent and live there for a very long time. The southern continent was once connected to other land areas as part of the ancient supercontinent called Gondwana. It was joined with South America, Africa, Australia, the Indian landmass, and Zealandia. Because these lands were connected, rivers carried minerals and nutrients into nearby seas, helping many forms of sea life grow. The coastlines stretched for great distances and included shallow bays, lagoons, river mouths, sandy beaches, rocky shores, and deeper waters farther from land. Each environment supported different animals, giving marine reptiles many places to hunt, rest, and reproduce. Marine reptiles did not begin their history in the sea. Their distant ancestors lived on land. Over many millions of years, some reptiles slowly adapted to life in water. Their bodies changed through natural selection, as those with features that helped them swim and hunt were more likely to survive and produce young. Legs slowly became better for moving through water. Tails became stronger for swimming. Their bodies became smoother, helping them move with less resistance. Some developed large flippers that worked like powerful paddles. Others relied mainly on their muscular tails for movement. Even though these animals spent almost all their lives in the ocean, they still breathed air. They had lungs instead of gills. This meant they had to return to the surface regularly to take in fresh air. Their nostrils were placed in positions that made breathing easier while floating at the surface. Some could stay underwater for long periods because their bodies stored large amounts of oxygen and used it efficiently while diving. The ancient seas around the southern continent were home to many groups of marine reptiles. Some were long-necked hunters that searched for fish and small animals. Others had large heads with powerful jaws filled with sharp teeth. There were also fast swimmers that chased prey across open water. Each group filled its own place within the ocean environment. One of the best-known groups was the plesiosaurs. These reptiles appeared during the Triassic period and survived until the end of the age of dinosaurs. Many species lived in the waters around the southern continent. Some had very long necks with many neck bones. Their small heads allowed them to move through schools of fish, while quickly catching prey with rows of pointed teeth. Their long necks helped them reach food without moving their larger bodies very much. This made it easier to surprise fish and squid-like animals. Plesiosaurs used 4 strong flippers to swim. Unlike many other sea animals, they did not depend mainly on their tails for movement. Their front and back flippers worked together, allowing them to travel through the water with steady strokes. Scientists studying their fossil bones have learned that this swimming method gave them excellent control while turning, diving, and changing direction. Not all plesiosaurs had long necks. Another group developed much shorter necks and much larger heads. These animals are known as pliosaurs. They were among the largest hunters in the ancient oceans. Their jaws held many strong teeth that could grip slippery prey. Some species reached enormous sizes and hunted fish, squid-like animals, sharks, and even other marine reptiles. Fossils found in rocks that were once part of the southern seas show that these powerful hunters lived in waters connected to Antarctica. The ancient seas also contained ichthyosaurs. These reptiles appeared early in the age of reptiles and became highly successful swimmers. Their bodies were shaped for speed. They had long snouts filled with many teeth that helped them catch fish and squid-like animals. Their eyes were very large, allowing them to see well even in dim light beneath the ocean surface. Some scientists believed they could dive to great depths where sunlight barely reached. Ichthyosaurs gave birth to live young instead of laying eggs on land. Fossils from different parts of the world have preserved mothers with unborn young still inside their bodies. This shows that they spent their entire lives in the water and did not need to leave the sea to reproduce. Their young entered the water immediately after birth and began swimming soon afterward. The waters around the southern continent changed over millions of years as sea levels rose and fell. During warmer times, shallow seas spread across large areas. During cooler periods, coastlines shifted as the amount of water stored in ice changed. Marine reptiles adapted to these changing environments by moving into new hunting grounds or following the animals they depended upon for food. Fish formed one of the main food sources for many marine reptiles. Ancient fish came in many sizes and shapes. Some traveled in large schools, giving predators many chances to feed. Others lived close to reefs or rocky shores where they searched for smaller animals. Fast swimmers often escaped danger, but many became meals for larger reptiles waiting nearby. Squid-like animals were another important source of food. Ancient relatives of modern squid, cuttlefish and octopuses filled the seas. Some had shells while others did not. These animals moved by pushing water from their bodies, allowing them to escape quickly. Marine reptiles developed sharp eyesight, quick movements, and fast attacks to catch them. The ancient oceans also contained ammonites. These shell-bearing animals belong to a group related to modern squid and octopuses. Their spiral shells came in many different sizes and patterns. Some floated in open water, while others stayed closer to the seafloor. Ammonites were abundant and formed an important part of the food web. Many marine reptiles probably hunted them whenever the opportunity appeared. Another common group included belemnites. These squid-like animals had hard internal structures that fossilized well. Their streamlined bodies helped them swim rapidly through the water. They gathered in large numbers, making them attractive food for many predators. Fossils of belemnites are often found alongside the remains of marine reptiles, showing that they shared the same environments. The seafloor supported many other living things. Shellfish buried themselves in soft mud. Sea urchins moved slowly across the bottom searching for food. Sea stars spread across rocks and sandy areas. Crinoids attached themselves to the seafloor where they collected tiny food particles from passing water. Sponges filtered water throughout the day. Corals formed structures that sheltered many smaller animals. All these creatures helped build healthy ocean ecosystems that supported larger predators higher in the food chain. Marine reptiles had different hunting methods depending on their bodies and the kinds of prey they preferred. Long-necked plesiosaurs quietly approached schools of fish before striking with their narrow heads. Pliosaurs relied on strength, rushing toward prey with wide-open jaws. Ichthyosaurs chased fast-moving animals across open water, using their speed and sharp eyesight. Each hunting style helped reduce direct competition for the same food. Many marine reptiles probably migrated over long distances. Ocean currents carried nutrients that attracted fish and squid-like animals. Predators often followed these food sources. As seasons changed, groups of marine reptiles may have traveled hundreds of miles through connected seas. Fossils discovered on continents that were once joined show that many species spread widely across the ancient southern oceans. The waters around Antarctica during much of the age of dinosaurs were not frozen. Forests grew on nearby land, rivers flowed into the sea, and temperatures remained warm enough to support rich marine life. Even during seasons with long periods of darkness near the poles, life continued. Animals adapted to changing amounts of daylight by adjusting their feeding, movement, and breeding activities. Early mammals, birds, and many other animals lived in prehistoric Antarctica during a time when the continent was very different from the frozen land that exists today. Millions of years before thick sheets of ice covered the continent, Antarctica had forests, rivers, lakes, wetlands, and long stretches of green land. The climate changed many times over Earth's history, and during long periods it was warm enough to support a rich variety of life. Animals that could never survive in modern Antarctica once found food, shelter, and places to raise their young there. Scientists have learned about these ancient animals by studying fossils buried in rocks across different parts of the continent. These fossils include bones, teeth, footprints, eggshell fragments, feathers, burrows, and tiny remains that reveal important details about the lives of animals that once lived there. The earliest mammals that reached Antarctica were small animals. They lived during the age when dinosaurs still ruled the land. These mammals were not large enough to compete directly with the biggest reptiles. Instead, they survived by feeding on insects, seeds, fruits, small reptiles, eggs, worms, and other food that was available in forests and along rivers. Most of these early mammals probably stayed hidden for much of the day, moving through thick plants, fallen logs, and underground shelters. Small body size helped them escape predators and allowed them to find food in places where larger animals could not reach. Many early mammals had bodies covered with hair. Hair helped keep their body temperature steady during cool nights and changing seasons. Even when Antarctica had a warmer climate than today, the continent still experienced long periods of darkness every year because of its position near the South Pole. Winters could become cool, although they were not filled with permanent ice. Hair gave mammals protection against cold weather and helped them remain active during different seasons. Scientists believe that many early mammals gave birth to live young, while others laid eggs. The ancestors of modern egg-laying mammals, known today as monotremes, may have been related to some ancient mammals that lived across Gondwana. Gondwana was the giant southern landmass that included Antarctica, Australia, South America, Africa, India, and several other land areas before these continents slowly separated. Because these lands remained connected for long periods, animals were able to move from one region to another without crossing wide oceans. Some early mammals belonged to a group called multituberculates. These mammals survived for a very long time during the age of dinosaurs and continued living after many dinosaurs disappeared. Their teeth had many small ridges that helped them grind seeds, leaves, and other plant material. Different species also ate insects and other small animals. Their strong jaws and special teeth allowed them to use many different food sources. Fossils found in southern continents suggest that relatives of these mammals may have lived in Antarctica's forests. Another important group of mammals included marsupial ancestors. Modern marsupials include animals such as kangaroos, koalas, wombats, and opossums. Ancient relatives of these animals spread across Gondwana before the continents separated completely. Fossil discoveries in Antarctica have shown that marsupials once lived there. These finds help scientists understand how marsupials spread between South America, Antarctica, and Australia, while land connections still existed. One important fossil from Antarctica belongs to an ancient marsupial called Antarctodolops. This animal lived after the great extinction that ended the age of non-avian dinosaurs. It was probably about the size of a modern rat or slightly larger. Its teeth suggest that it fed mainly on fruits, seeds, leaves, and perhaps insects. The discovery of Antarctodolops shows that mammals quickly became an important part of Antarctica's ecosystems after many dinosaurs disappeared. Scientists have also discovered fossils of other ancient mammals from the early part of the Age of Mammals in Antarctica. Some belong to groups that are now extinct, while others were early relatives of mammals that still exist today. Their teeth provide valuable information because tooth shape often reveals what an animal ate. Sharp teeth usually suggest eating meat or insects, while broad teeth often indicate eating plants. Tiny marks on tooth surfaces can even show the kinds of food that animals regularly chewed. The forests of prehistoric Antarctica supported many insects, making insect-eating mammals common. Beetles, flies, dragonflies, termites, ants, and many other insects lived among trees, flowers, dead wood, and wet soil. Small mammals hunted these insects during the day or at night. Some may have climbed trees in search of food, while others searched through leaf litter covering the forest floor. Their excellent sense of smell and hearing helped them locate hidden prey. Some mammals probably dug burrows underground. Burrows protected them from predators, changing weather and seasonal temperature changes. Underground shelters also provided safe places to raise young. Fossil burrows found in ancient rocks show that digging behavior existed in many prehistoric animals. Although it is often difficult to know exactly which animal created a particular burrow, these underground homes reveal how animals adapted to their environment. Large flowering plants spread across Antarctica during later parts of the age of dinosaurs and became even more common afterward. Their fruits, seeds, flowers, and leaves provided food for many mammals. Plants and mammals developed close relationships over time. Mammals carried seeds to new places after eating fruit. Some seeds passed through the digestive system and later grew into new plants. Other seeds attached themselves to animal fur and were carried across forests. Birds also became important members of prehistoric Antarctica's ecosystems. The earliest birds evolved from small feathered dinosaurs. Over millions of years, they developed stronger flying abilities, lighter skeletons, improved feathers, and more efficient breathing systems. By the time forests covered Antarctica, several kinds of birds were already living across different parts of the world. Some early birds probably spent much of their time in trees. They searched for insects among branches, built nests, and raised their young above the forest floor where many predators hunted. Strong claws allowed them to grip branches securely. Different beak shapes allowed different species to feed on insects, fruits, seeds, fish, or small animals. Feathers served many important purposes. They helped birds fly, kept their bodies warm, protected their skin, and played roles during courtship. Even flightless birds had feathers for warmth and protection. Fossil feathers discovered around the world have helped scientists understand how feathers developed from simple structures into the complex forms seen in modern birds. The long periods of daylight and darkness that occurred each year in Antarctica affected bird behavior. During the long summer days, birds had many hours to gather food, feed their young, and build up energy reserves. During the darker winter months, food supplies changed. Some birds may have remained throughout the year, while others probably migrated northward before returning during warmer seasons. Migration likely became an important survival strategy. For some bird species, birds capable of long-distance flight could leave Antarctica before harsh weather arrived and return when food became plentiful again. Land connections and shorter distances between southern continents during different periods made movement easier than it is today. Bird nests were built in many different locations. Some birds nested in tree branches, others used hollow trunks, while ground nesting species laid eggs among thick plants or sandy riverbanks. Parents protected eggs from predators and changing weather. Many birds cared for their chicks by bringing insects, seeds, fish, or other food until the young became independent. Fossil eggshells provide valuable evidence about prehistoric birds. The thickness of shells, their surface patterns, and tiny openings that allowed air to pass through help scientists identify different groups. Even broken eggshell fragments can reveal information about nesting habits and breeding environments. Some birds hunted fish in rivers, lakes, and coastal waters. Long beaks allowed them to catch slippery prey. Others searched shallow water for insects, shellfish, worms, and small amphibians. Wetlands supported rich communities of animals that provided food throughout much of the year. After the extinction of non-avian dinosaurs, birds became even more diverse. Without many large reptile predators dominating the land, birds spread into new habitats and developed many different ways of living. Antarctica supported several bird groups during this period, as forests continued covering much of the continent. Among the most remarkable birds known from Antarctica are ancient relatives of modern waterfowl. Fossils suggest that ducks, geese, and related birds had early ancestors living in southern regions. Rivers, lakes, and wetlands gave these birds excellent feeding grounds, where they searched for aquatic plants, insects, fish, and small water animals. Another famous group includes giant, flightless birds, those that lived much later after Antarctica had begun cooling. Some ancient relatives of modern birds became large predators. These birds walked on powerful legs and hunted smaller animals across open landscapes. Although most famous examples are known from South America, scientists continue studying Antarctic fossils to understand how different bird groups spread across southern continents. Penguins became one of Antarctica's most successful bird groups. The earliest penguins appeared after the extinction of non-avian dinosaurs, when Antarctica still had a much warmer climate than today. Ancient penguins looked different from modern species. Some were much taller and had longer beaks. They could not fly through the air but were excellent swimmers. Their wings changed into strong flippers that pushed them through water while chasing fish, squid, and other sea animals. Early penguins lived along coastlines where rich oceans supplied abundant food. Fossils show that several different penguin species existed in Antarctica during warm periods. Some stood taller than most living penguins. Their bones reveal powerful swimming muscles and thick skeletons that helped them dive beneath the water. One ancient penguin known from Antarctica is Anthropornis. This bird reached an impressive height and lived during a time when forests still existed in parts of the continent. Another ancient penguin called Palaeodiptes also lived in Antarctic waters. These birds hunted fish and squid while avoiding large marine predators. The oceans around prehistoric Antarctica supported many seabirds besides penguins. Flying birds searched open water for fish, squid, and crustaceans. Strong winds over the Southern Ocean helped many birds travel great distances while using little energy. Coastal cliffs and rocky shores provided nesting sites that remained relatively safe from land predators. Reptiles continued sharing Antarctica with mammals and birds for millions of years. Small lizards hunted insects among rocks and fallen branches. Turtles lived in rivers and lakes where they fed on plants, insects, fish, and other small animals. Crocodile relatives occupied warmer wetlands and river systems during periods when Antarctica's climate remained mild enough to support them. Snakes may also have reached Antarctica during warm periods. Fossils from nearby southern continents show that snakes were spreading across Gondwana. Although snake fossils are rare in Antarctica, scientists believe suitable habitats existed during warmer times. Amphibians formed another important part of prehistoric Antarctica's animal life. Frogs, salamanders, and their relatives depended on fresh water for breeding. Wet forests, ponds, streams and marshes gave them places to lay eggs. Their soft skin required moist conditions, making Antarctica's ancient wetlands ideal habitats before the continent became cold and dry. Frog calls probably filled wetlands during breeding seasons. Males attracted females through sounds, while eggs developed in calm water. Young tadpoles fed on tiny plants before changing into adult frogs. Salamanders hunted insects, worms, and other small animals beneath leaves and logs. Fish thrived in Antarctica's rivers, lakes, and coastal waters. Freshwater fish lived among underwater plants and rocky streams. Some species fed on insects that fell into the water, while others hunted smaller fish. Coastal waters supported many marine fish that became food for birds, marine reptiles, sharks, and early marine mammals during later periods. Sharks had already existed for hundreds of millions of years before mammals became common. Several shark species swam through the seas surrounding Antarctica. Some hunted fish while others fed on shellfish and other marine animals living along the sea floor. Rays also lived in ancient Antarctic waters. Their flattened bodies allowed them to rest on sandy bottoms where they searched for shellfish, worms, and small fish. Fossil teeth and other remains help scientists identify these ancient sea animals. Many kinds of shellfish lived in rivers, lakes, and oceans. Clams, snails, oysters, ammonites during earlier periods, and many other animals formed an important part of aquatic food chains. Their shells are often preserved as fossils because hard shells survive burial better than soft body tissues. Crabs and other crustaceans occupied coastal waters and river mouths. They searched for dead animals, plants, worms, and smaller creatures. Their hard outer covering protected them from many predators. Fossils show that crustaceans played important roles in ancient marine ecosystems. Insects were among the most successful animals in prehistoric Antarctica. Beetles formed one of the largest insect groups. They lived under bark, inside dead wood, beneath leaves, and in flowers. Different beetles fed on plants, fungi, insects, or dead animals. Their strong outer covering reduced water loss and protected their bodies. Dragonflies flew above ponds and rivers, hunting smaller insects. Their large eyes gave them excellent vision. Young dragonflies lived underwater before changing into flying adults. Healthy freshwater habitats supported large dragonfly populations. Butterflies and moths became more common as flowering plants spread. Adult butterflies drank nectar from flowers while helping move pollen between plants. Caterpillars fed on leaves, becoming food for birds, reptiles, amphibians, and small mammals. Bees also developed close relationships with flowering plants. As they collected nectar and pollen, they transferred pollen from one flower to another, allowing plants to produce seeds. This partnership became one of the most important processes supporting forest ecosystems. Ants formed organized colonies beneath the ground, inside rotten wood, and among tree roots. Different workers gathered food, cared for young, defended nests, and built tunnels. Ant colonies helped break down dead plants while moving soil and spreading seeds. Termites fed mainly on dead wood. Their ability to digest tough plant material made them important recyclers in forest ecosystems. Fallen trees gradually disappeared as termites, fungi, and bacteria broke them down into nutrients that returned to the soil. Spiders hunted insects throughout Antarctica's forests. Some built webs between branches, while others chased prey across leaves and tree trunks. Their role in controlling insect populations helped maintain balance within forest communities. Scorpions may also have lived in warmer parts of prehistoric Gondwana, although Antarctic fossil evidence remains limited. Other relatives of spiders certainly occupied forest habitats where they hunted small animals. Earthworms lived in moist soil where they fed on decaying plant material. Their movement mixed the soil, allowing air and water to reach plant roots more easily. Countless tiny organisms shared the soil with them, including fungi, bacteria, and microscopic animals that helped recycle nutrients. Many forests contained fallen trees that slowly decayed over many years. These logs became homes for insects, fungi, mosses, reptiles, amphibians, mammals, and countless tiny animals. Every stage of decay supported different living creatures. Predators and plant eaters depended upon one another. Small mammals became food for birds of prey, reptiles, and larger mammals. Insects became food for amphibians, birds, reptiles, spiders, and mammals. Fish fed birds, reptiles, and larger fish. Dead animals provided food for insects, fungi, bacteria, and scavengers. Every living thing formed part of connected food systems. The changing seasons affected every animal living in prehistoric Antarctica. During long summer days, plants grew quickly, insects became abundant, and many animals reproduced. Young animals had greater access to food during these productive months. As winter approached, leaves fell from many trees, temperatures dropped, and food became less available. Some mammals stored food, others developed thicker coats before colder weather. Birds migrated or remained near reliable food sources. Reptiles became less active during cooler periods. Amphibians stayed hidden in moist places until conditions improved. Forest fires occasionally changed parts of prehistoric Antarctica. Lightning strikes during dry seasons could start fires that spread through forests. Although fires destroyed plants in some places, they also created new habitats where fresh vegetation later grew. Many animals escaped by running, flying, burrowing, or moving into rivers and lakes. Floods also shaped animal life. Heavy rainfall caused rivers to overflow, creating new lakes, wetlands, and channels. Floods sometimes buried animals and plants beneath layers of mud that later hardened into rock. Many fossils exist today because rapid burial protected remains from scavengers and weather. Volcanic activity influenced Antarctica throughout much of its history. Ash falling from eruptions sometimes covered forests and lakes. Although eruptions killed plants and animals near volcanoes, volcanic ash later enriched soils with minerals that supported new plant growth. As Antarctica slowly drifted farther south because of plate movement, its climate gradually cooled. Forest habitats slowly changed. Some animal groups adapted to cooler conditions, while others moved into South America or Australia before land connections disappeared. Those unable to adapt eventually disappeared from Antarctica. The opening of ocean passages around Antarctica changed ocean currents. Cold water began circulating around the continent, reducing temperatures further. Ice sheets slowly expanded. Forests became smaller, wetlands disappeared, and habitats suitable for mammals, reptiles, amphibians, and many birds steadily declined. Penguins remained among the animals best able to survive the cooling environment because they depended mainly on the ocean. Marine food remained available even as conditions on land became much harsher. Other seabirds also continued using Antarctic coastlines. Most land mammals eventually disappeared from Antarctica as permanent ice spread across the continent. Reptiles and amphibians vanished because the climate became too cold for them. Insects became much less diverse than they had been during warmer ages. The rich forests that had supported countless species were gradually replaced by ice, snow, exposed rock, and small patches of hardy plants that could survive freezing conditions. Today, scientists continue discovering fossils across Antarctica, despite the difficult working conditions. Expeditions search mountain slopes, exposed rock formations and coastal cliffs where ancient rocks reach the surface. During the short Antarctic summer, researchers collect fossils, map rock layers, study ancient environments, and transport specimens to laboratories for careful examination. Modern technology has greatly improved fossil research. High-resolution imaging allows scientists to examine tiny details inside fossils without damaging them. Chemical studies reveal information about ancient diets, climates, and environments. Computer models help researchers rebuild ancient animals from incomplete skeletons. Tiny grains of fossil pollen and spores found in rock samples reveal the kinds of plants that surrounded ancient mammals, birds, and other animals. Each fossil discovery adds another piece to the history of prehistoric Antarctica. Teeth reveal diets, bones show movement, feathers provide information about birds, burrows reveal behavior, eggshells record reproduction. Fossil footprints preserve moments when animals crossed soft ground near rivers, lakes, beaches, or forest floors. Together, these discoveries show that prehistoric Antarctica supported a wide variety of mammals, birds, reptiles, amphibians, fish, insects, and countless other living creatures across millions of years, while the continent remained warm enough to support forests, wetlands, freshwater systems, and rich coastal environments. Fossils hidden beneath the ice of Antarctica have changed the way scientists understand the history of the southern continent. Today, Antarctica is covered by a huge sheet of ice that reaches great thickness across most of its land. Strong winds, freezing temperatures, and long periods of darkness make it one of the hardest places on Earth to explore. At first sight, it may seem impossible that this frozen land could hold evidence of forests, rivers, dinosaurs, early birds, ancient mammals, and many other forms of life. Yet beneath the ice and within the exposed rocks around the edges of the continent, scientists have found fossils that tell the story of a very different Antarctica. A fossil is the preserved remains or trace of an ancient living thing. Fossils may include bones, teeth, shells, leaves, wood, pollen, footprints, eggs, burrows, or even marks left behind by animals as they moved across soft ground. Over a very long time, these remains become buried under layers of mud, sand, ash, or other material. Minerals slowly replace parts of the original remains or fill empty spaces, helping preserve their shape. In some cases, only an impression remains, but even that can provide valuable information about the living thing that left it behind. Finding fossils in Antarctica is much harder than finding them in many other parts of the world. Most of the continent is hidden beneath thick ice that has covered the land for millions of years. Only a small part of the land is free of ice during the warmer months. These exposed areas are usually found along the coast, on mountain slopes and in valleys where strong winds or natural conditions have prevented ice from remaining. These rocky places give scientists their best chance to study the ancient history of the continent. Before any expedition begins, researchers spend many months preparing. Antarctica is one of the most remote places on Earth, so every trip requires careful planning. Teams must decide where they want to search, how they will travel, what equipment they will need, and how long they can safely remain in the field. They also study maps, satellite images, and earlier research to identify rock formations that may contain fossils. Scientists know that fossils are most often found in sedimentary rocks. These rocks form when layers of sand, mud, and other materials settle over long periods. As these layers become buried, they slowly harden into rock. Living things that were buried within these layers may become fossils. Because of this, Researchers pay close attention to places where sedimentary rocks are exposed above the ice. Modern satellite images help scientists identify areas where rocks are visible. Satellites can show the shape of mountains, valleys, cliffs, and other landforms even in remote parts of Antarctica. Researchers examine these images carefully before traveling. They may also use information collected by aircraft that carry special instruments capable of measuring the land beneath the ice. These tools help scientists understand the hidden shape of the continent and identify places where ancient rocks may be close to the surface. Many fossil discoveries begin with long journeys across the frozen landscape. Scientists often travel by research ship to reach the Antarctic coast. From there, they may use helicopters, snow vehicles, or small aircraft to reach their camps. In some places, they must continue on foot while carrying equipment across rocky ground. Every movement must be planned carefully because sudden weather changes can make travel dangerous. Research camps are built to support the scientists during their work. These camps usually include sleeping tents, cooking areas, storage for food and equipment, communication systems, and emergency supplies. Team members must work together to keep the camp safe while also carrying out their scientific studies. Daily weather reports help them decide when it is safe to leave camp and when they should remain sheltered. Once researchers reach an area with exposed rocks, they begin searching carefully. Fossils are rarely found by simply digging random holes. Instead, scientists slowly examine the surface of the rocks, looking for shapes, colors, textures, or patterns that stand out from the surrounding stone. Years of experience help paleontologists recognize the small signs that may reveal a fossil. Sometimes only a tiny piece of bone is visible. A single fragment sticking out from a rock may lead to the discovery of an entire skeleton buried inside. In other cases, part of a fossilized leaf or a piece of ancient wood may appear along the edge of a cliff. Even a small discovery can encourage researchers to spend many days studying the surrounding rocks. The layers of rock are just as important as the fossils themselves. Scientists carefully record the exact position where each fossil is found. They note the height of the rock layer, its color, the size of the grains within the rock, and the types of other rocks nearby. This information helps them understand the environment in which the ancient plant or animal lived. Every fossil is photographed before it is removed. Researchers take pictures from different angles and often place measuring tools beside the fossil, so that its size can be recorded accurately. They also mark its location using modern positioning equipment. This creates a detailed record that can be studied later, even after the fossil has been removed. Removing a fossil requires great care. Scientists cannot simply pull it from the rock, because doing so may damage the specimen. Instead, they use small tools such as brushes, fine picks, chisels, and rock hammers. Loose material is removed slowly until the fossil becomes fully visible. Every movement is made with patience because a mistake could destroy details that have survived for millions of years. Some fossils are so delicate that special chemicals are applied to strengthen them before they are removed. These materials soak into small cracks and help prevent the fossil from breaking apart. Scientists may repeat this process several times while continuing to expose more of the specimen. When a large fossil is discovered, removing it becomes a much bigger task. A dinosaur bone, for example, may still be surrounded by a large block of rock. Instead of trying to separate the fossil from the rock in the field, researchers remove the entire block. The fossil can then be cleaned more carefully later in a laboratory where better tools and controlled conditions are available. To protect large fossils during transport, scientists often wrap them in layers of soft material before covering them with strong plaster jackets. These hard coverings hold the rock together while it is carried from the field. The plaster forms a protective shell around the fossil, reducing the chance that it will break during the long journey back to a research station. Weather can interrupt fossil work at any moment. Strong winds may suddenly fill the air with blowing snow, making it difficult to see. Temperatures can fall quickly, forcing the team to stop working and return to camp. Because of these conditions, scientists sometimes have only a short period each day when they can safely search for fossils. The short Antarctic summer provides the best opportunity for fossil hunting. During this season, there are many hours of daylight, allowing researchers to spend more time working outside. Even then, temperatures often remain below freezing, and snowstorms may still occur without much warning. Many important fossil sites are found in mountain ranges where erosion has exposed ancient rocks. Wind, freezing and thawing slowly wear away the surface, uncovering fossils that had been hidden inside the rock. Scientists carefully examine these natural exposures because they may reveal fossils that would otherwise remain buried. Glaciers also play a role in revealing ancient remains. As glaciers slowly move across the land, they grind against the rocks beneath them. This movement can expose older rock layers or carry loose pieces of fossil-bearing rock to new locations. Researchers sometimes study these transported rocks to trace them back to their original source. Finding the original location of a fossil is very important. A loose fossil tells scientists about the animal or plant itself, but a fossil found within its original rock layer provides much more information. It reveals the age of the fossil, the environment in which it lived, and the events that took place after it was buried. Scientists use many different methods to estimate the age of fossil-bearing rocks. One method involves studying nearby volcanic ash layers. Volcanic eruptions spread ash over large areas. When this ash becomes buried, it forms a thin layer within the rocks. Minerals inside the ash contain tiny amounts of radioactive elements that change slowly over time. By measuring these changes, scientists can estimate when the ash was formed, giving an age for the surrounding rocks. Other fossils can also help determine age. Certain small marine animals, tiny plant remains, and microscopic organisms lived during limited periods in Earth's history. When these fossils are found together with larger fossils, they help researchers estimate the age of the rock layers in which they occur. Microscopic fossils are especially valuable in Antarctica. Small grains of pollen, spores from ancient plants, and tiny marine organisms can survive for millions of years. Scientists collect rock samples and examine them under powerful microscopes. These tiny fossils provide clues about the kinds of plants growing at the time and the climate in which they lived. The oldest rocks found in Antarctica formed during the earliest part of Earth's history. At that time, the planet itself was still changing after its formation. The surface was much hotter than it is today. Volcanoes were very active, and gases released from Earth's interior slowly built the early atmosphere. Oxygen was almost completely absent. The air was mostly made up of carbon dioxide, water vapor, nitrogen, and other gases released through volcanic activity. Antarctica did not exist as a separate continent during this distant time. The land that would later become Antarctica was part of much larger pieces of Earth's crust that slowly moved over millions of years. During the Archean age, Earth's climate remained warmer than it is today, because the atmosphere contained large amounts of greenhouse gases. These gases trapped heat and helped keep the planet warm, even though the young sun gave off less energy than it does now. Oceans covered much of Earth's surface, and early forms of life began to appear. These tiny living things mostly lived in the oceans. They included simple bacteria and other microscopic organisms that slowly changed the atmosphere by producing oxygen through photosynthesis. This process took an extremely long time, but it eventually increased the amount of oxygen in the air. As oxygen levels slowly rose during the Proterozoic age, Earth's climate continued to change. There were times when large ice sheets spread across many parts of the world. Scientists believe that some of these cold periods may have covered much of Earth with ice. The land that later became Antarctica experienced these changes along with other parts of the planet, because the continents were arranged very differently from their modern positions. Rocks from Antarctica contain evidence of ancient glaciers that formed during some of these early cold periods. These rocks show marks left by moving ice, including scratches and deposits carried by glaciers. The movement of Earth's tectonic plates continued throughout this long period. Pieces of land slowly joined together and later separated again. Antarctica became part of several ancient supercontinents before eventually joining the giant landmass known as Gondwana. This large supercontinent included the lands that later became Africa, South America, Australia, India, Madagascar, and the Arabian Peninsula. Since these lands were connected, plants and animals could spread across wide areas without crossing large oceans. During the Cambrian period, life in the oceans became much more diverse. The climate was generally warm and shallow seas covered many low areas of the continents. Antarctica was still part of Gondwana and lay much farther north than it does today. Fossils from this period found in Antarctica include many sea animals that lived in warm marine environments. These fossils help scientists understand that the climate supported rich ocean life. During the Ordovician period, the climate changed several times. At first, conditions remained warm, allowing marine life to continue spreading. Later in the period, Earth entered a colder phase. Large glaciers formed across parts of Gondwana, including areas that would later become Antarctica. Evidence for these glaciers comes from rocks containing material carried and dropped by moving ice. The growth of these glaciers caused sea levels to fall because large amounts of water became trapped in ice sheets. The Silurian period followed, bringing warmer conditions again as many glaciers melted. Sea levels rose once more, flooding coastal regions around the world. Antarctica experienced these warmer conditions along with the rest of Gondwana. Marine life recovered after the earlier cold period, and many new species appeared in the oceans. The climate supported healthy marine ecosystems filled with fish, shellfish, corals, and many other sea creatures. During the Devonian period, the climate remained mostly warm across much of the world. Plants spread across land in greater numbers than before. The earliest forests began to develop in many regions. Antarctica supported plant life because its climate was much milder than today. Fossils of ancient plants found in Antarctic rocks show that vegetation was becoming more common. Rivers carried sediment across the land, forming floodplains where plants could grow. Seasonal rainfall helped support these early ecosystems. The Carboniferous period brought important climate changes. Large forests spread across Gondwana. Antarctica supported extensive plant communities made up of seed ferns, early conifers, horsetails, club mosses, and ferns. Thick layers of plant material collected in wetlands and swamps. Over long periods, some of this material became coal. Coal deposits found in Antarctica today show that forests once covered parts of the continent. Such forests could only exist because the climate was far warmer than modern Antarctic conditions. Although Antarctica was moving slowly toward the South Pole during this time, it was still able to support abundant plant life. The continent experienced long periods of daylight during summer and long periods of darkness during winter because of its high southern latitude Even with these unusual daylight patterns, the climate remained warm enough for forests to grow. Plants adapted to these changing light conditions and continued to thrive throughout much of the year. During the Permian period, Gondwana experienced both warm and cool phases. Glaciers expanded across some regions during colder intervals, leaving behind clear evidence in the rocks. Later, warmer conditions returned in many places. Antarctica remained covered by forests in several areas, despite these climate changes. Fossils of the seed fern Glossopteris became especially common. These fossils have been found across many parts of Gondwana, helping scientists understand that these continents were once joined together. The climate during the Permian also supported many insects, amphibians, and reptiles. Rivers continued to flow across Antarctica, carrying sand and mud that formed thick sedimentary rock layers. Lakes appeared in low areas where water collected. Seasonal rainfall provided fresh water for plants and animals living across the landscape. Toward the end of the Permian period, Earth experienced one of the largest mass extinction events in its history. Massive volcanic eruptions released huge amounts of gases into the atmosphere. Carbon dioxide levels increased greatly, leading to major climate changes. Temperatures rose, ocean chemistry changed, and many living species disappeared. Antarctica was affected along with the rest of the world. Fossil records show major changes in plant and animal communities after this event. The Triassic period began after this great extinction. The climate across much of the world became warmer and drier. Antarctica remained connected to the other parts of Gondwana. Although some regions became dry, many parts of Antarctica still supported forests, rivers, and lakes. Early dinosaurs appeared during this period, along with many reptiles and the earliest mammals. Fossils found in Antarctica show that these animals lived in environments that were suitable for life despite the seasonal darkness experienced each year. The atmosphere during the Triassic contained much higher levels of carbon dioxide than today. These greenhouse gases helped maintain warm temperatures even in high southern latitudes. Polar ice was either absent or extremely limited. Scientists believe that snowfall rarely remained on the ground throughout the year because temperatures were generally too high for permanent ice sheets to develop. Volcanic activity remained common during this period. Large volcanic eruptions released ash, gases, and lava across many regions. These eruptions sometimes caused short periods of cooling by placing particles high into the atmosphere. Over longer periods, however, the release of greenhouse gases contributed to overall warming. Antarctica's climate reflected these long-term changes as forests continued growing across much of the continent. The Jurassic period brought another long interval of warm conditions. Dinosaurs became larger and more diverse. Antarctica supported many kinds of plants, including conifers, cycads, ginkgos, ferns, and seed ferns. Rivers flowed across broad valleys and lakes formed in many regions. Rainfall supported thick vegetation. Fossils show that dinosaurs lived throughout Antarctica during this time, feeding on the plants that covered the landscape. The continent remained free of permanent ice sheets. Winters were dark because of Antarctica's position near the South Pole, but temperatures remained mild enough for forests to survive. Trees adapted by slowing their growth during the darker months and growing more actively when sunlight returned. Tree rings preserved in fossil wood help scientists understand these seasonal growth patterns. Large rivers carried sediment into lakes and coastal areas. These sediments buried dead plants and animals, helping preserve them as fossils. Each new layer protected older remains from weathering. Over millions of years, these layers became valuable records of ancient climate and ecosystems. The oceans surrounding Antarctica were also much warmer than today. Marine reptiles swam through these waters, along with fish, ammonites, shellfish, and many other sea animals. Warm ocean currents carried heat towards the southern regions, preventing the formation of permanent sea ice. Coastal environments supported rich marine life that has been preserved in fossil deposits. The breakup of Gondwana slowly began during the Jurassic period. Large cracks developed within the supercontinent as tectonic forces gradually pulled the land apart. Although this movement happened very slowly, it eventually changed ocean circulation and climate across the southern hemisphere. Antarctica remained connected to Australia and South America for much of this period, allowing plants and animals to continue spreading between these lands. The Cretaceous period continued the generally warm climate. In many places around the world, the sea levels became very high because little water was locked away in glaciers. Antarctica remained covered with forests across large regions. Flowering plants began spreading during this time, adding new forms of vegetation to the landscape. Conifers continued growing alongside these newer plants, creating diverse forests that supported many different animals. Dinosaurs remained common throughout much of the Cretaceous period. Fossils found in Antarctica include meat-eating dinosaurs as well as plant-eating species. These animals lived in climates that experienced cool winters, but remained far warmer than present-day Antarctic conditions. Rainfall supported rivers, lakes, and wetlands where many species gathered for food and water. Scientists studying fossil leaves from Antarctica have found evidence that temperatures remained mild enough for active plant growth during much of the year. The shape, size, and structure of these fossil leaves provide important information about ancient rainfall, humidity, and temperature. Fossil pollen and spores preserved in sediment also help scientists identify the kinds of plants that lived there and the climates they required. The atmosphere during the Cretaceous contained higher levels of carbon dioxide than today. This helped keep global temperatures elevated. Warm oceans transferred heat toward polar regions, reducing temperature differences between the equator and the poles. Permanent ice sheets remained absent across Antarctica for much of this time. Mass extinctions are periods in Earth's history when a very large number of living species disappeared within a relatively short time in geological terms. These events affected life on land, in the oceans, and in the air. They changed the direction of evolution and allowed different groups of plants and animals to spread into places that had become empty after many earlier forms of life disappeared. Antarctica was part of these major changes, even though it looked very different from the frozen continent that exists today. During much of its early history, Antarctica had forests, rivers, lakes, wetlands, and a climate that could support many kinds of living things. The record of these ancient environments is preserved in rocks, fossils, pollen, and other remains that scientists continue to study. These discoveries help explain how mass extinctions affected Antarctica and the life that once lived there. The earliest known mass extinction happened near the end of the Ordovician period, about 444 million years ago. At that time, Antarctica was located much closer to the South Pole than it is today. Large ice sheets formed across parts of the continent. The growth of these ice sheets caused sea levels around the world to fall because large amounts of water became locked up in ice. Many shallow seas became smaller or disappeared completely. These shallow seas had been home to countless marine animals, including brachiopods, trilobites, corals, bryozoans, and many other forms of sea life. As their habitats disappeared, many species died out. The cooling climate also affected ocean temperatures and ocean circulation. Many marine organisms depended on stable conditions for survival. Sudden changes in temperature and water depth placed great stress on these living things. Animals that could not adapt to the new conditions gradually disappeared. Antarctica played an important role in this event because its growing ice sheets influenced sea levels across the planet. Rocks found in Antarctica preserve signs of ancient glaciers that formed during this period, helping scientists understand the connection between climate change and widespread extinction. After the ice sheets later melted, sea levels rose again. Some species recovered and new species appeared. The oceans slowly became home to different communities of animals. Evolution continued as surviving species spread into habitats left empty by those that had disappeared. Antarctica remained part of these changing environments as marine life slowly became more diverse once again. Another major extinction happened near the end of the Devonian period, about 359 million years ago. This extinction did not happen all at once. Instead, it took place through several stages over a long period. During this time, large forests spread across many parts of the world. These forests changed the atmosphere and influenced the movement of nutrients into rivers and oceans. Changes in ocean chemistry led to low oxygen levels in many seas. Marine animals that depended on oxygen-rich water struggled to survive. Coral reefs were among the environments most heavily affected. Reef-building organisms disappeared in many places. Fish groups that had once been successful also suffered major losses. Antarctica was still connected to other southern continents as part of the ancient landmass known as Gondwana. Rivers carried sediments and plant material into nearby seas. These changes influenced local environments and affected marine ecosystems around the continent. Fossils from rocks of this age show that marine communities changed greatly after the extinction. Some groups became much less common while others slowly increased in number. Plants on land also continued to develop, providing new habitats for insects and early land animals. Antarctica shared these changes because it supported plant life and freshwater environments that were linked to the larger ecosystems of Gondwana. The largest mass extinction in Earth's history happened near the end of the Permian period, about 252 million years ago. This event is often called the Great Dying because such an enormous number of species disappeared. Scientists believe that huge volcanic eruptions released massive amounts of carbon dioxide and other gases into the atmosphere over a long period. These eruptions took place in what is now northern Asia. The gases changed the climate, warmed the planet, affected rainfall, and changed the chemistry of the oceans. Ocean waters became warmer and contained less oxygen. Some parts of the oceans became almost unable to support complex life. Acidification also damaged many organisms that built shells or skeletons from calcium carbonate. Entire ecosystems collapsed. Countless marine species disappeared forever. Antarctica was still covered with forests, rivers, lakes, and wetlands during much of this time. Fossils found there show that seed ferns, called Glossopteris, formed widespread forests across the continent. These forests supported insects, amphibians, reptiles, and many smaller organisms. As climate conditions became more difficult, these forests declined. The disappearance of Glossopteris marked one of the major plant losses, connected with the end of the Permian extinction. The loss of these forests affected many other living things. Animals that depended on the plants for food or shelter faced increasing difficulty. Insects that fed on certain leaves lost their food sources. Soil organisms experienced changes as dead plant material became less common. Rivers carried different amounts of sediment because fewer roots held the soil together. Wetland environments also changed as plant communities disappeared. The extinction did not affect every species in the same way. Some plants survived and later spread into areas where forests had vanished. Some reptiles and amphibians managed to survive despite the harsh conditions. These survivors became the ancestors of many later groups that lived during the Triassic period. The recovery after the end of the Permian extinction took millions of years. Antarctica's ecosystems slowly became more stable as new plants appeared and forests gradually returned in different forms. Fossils show that new species replaced many of those that had disappeared. The balance of life had changed greatly, and Antarctica entered a new stage in its natural history. During the Triassic period, Antarctica remained connected to the other southern continents. The climate was generally much warmer than today. Forests covered large areas, and rivers flowed across broad plains. Dinosaurs first appeared during this period, although they were not yet the dominant land animals. Other reptiles, amphibians, and early mammals also shared these environments. Near the end of the Triassic period, about 201 million years ago, another mass extinction took place. Scientists believed that enormous volcanic eruptions associated with the opening of the Atlantic Ocean released large amounts of greenhouse gases into the atmosphere. These eruptions continued for many thousands of years and changed the climate across much of the world. Many groups of reptiles disappeared during this extinction. Numerous marine animals also became extinct. The loss of these species opened opportunities for dinosaurs to become the most successful large land animals during the Jurassic period. Antarctica experienced these changes along with the rest of Gondwana. Fossils found on the continent show that dinosaurs became more common after the extinction. Different kinds of plant-eating and meat-eating dinosaurs eventually spread across Antarctic forests. The vegetation also changed as some plant groups declined, while others became more widespread. The forests continued to support many kinds of life. Conifers, ferns, seed ferns, horsetails, and other plants formed rich ecosystems. Small mammals lived alongside dinosaurs. Early birds had not yet appeared, but many reptile groups filled important roles within these environments. The extinction at the end of the Triassic did not completely destroy Antarctic ecosystems. Instead, it changed which groups of organisms became most successful. Dinosaurs expanded into habitats that had once been occupied by other reptiles. Their success continued throughout the Jurassic and much of the Cretaceous period. The Jurassic period brought warm conditions to Antarctica despite its high southern location. Forests remained widespread and long summer daylight helped plants grow during a part of the year. Winters were dark, but the climate was still mild enough to support abundant vegetation. Large dinosaurs moved through these forests while smaller animals searched for food beneath the trees. Marine life also flourished in the seas surrounding Antarctica. Ammonites, marine reptiles, fishes, and many kinds of shellfish lived in coastal waters. These seas supported rich food webs that connected land and ocean environments. Rivers carried nutrients into the sea, helping support many marine organisms. The Cretaceous period continued many of these conditions. Flowering plants began spreading across different parts of the world, including Antarctica. These new plants added greater variety to forests and created additional food sources for insects and plant-eating animals. Insects became more diverse as they developed relationships with flowering plants. Birds also became more common during this time. Dinosaurs remained the largest land animals in Antarctica. Fossils discovered on the continent include armored dinosaurs, duck-billed dinosaurs, meat-eating dinosaurs, and smaller species. These animals lived in forests that experienced months of darkness during winter, but remained productive enough to support large populations. Near the end of the Cretaceous period, About 66 million years ago, another major mass extinction occurred. Scientists widely agree that a large asteroid struck Earth in what is now Mexico. The impact released enormous amounts of energy. Dust, ash, and tiny rock particles entered the atmosphere and spread around the world. Large wildfires may also have started in many regions. Sunlight reaching Earth's surface decreased, as particles blocked part of the incoming light. Plants struggled because they depended on sunlight to produce food. As plant growth declined, plant-eating animals lost important food sources. Meat-eating animals also suffered because the animals they hunted became less common. Food chains broke down across land and sea. Antarctica experienced these worldwide effects even though it was far from the impact site. Fossil evidence suggests that forests on the continent suffered damage, but many plants survived. Some scientists believe that Antarctica may have provided environments where certain species found temporary refuge because local conditions remained suitable for survival in some places. The extinction ended the age of non-avian dinosaurs. Every known species of these dinosaurs disappeared. Flying reptiles known as pterosaurs also became extinct. Many marine reptiles vanished. Ammonites, which had lived in Earth's oceans for hundreds of millions of years, disappeared completely. Not every group suffered equally. Birds survived because they belonged to one branch of the dinosaur family that managed to live through the disaster. Mammals also survived and later became much more diverse. Crocodiles, turtles, frogs, salamanders, and many fish continued to exist. Many flowering plants recovered and spread once environmental conditions improved. Antarctica entered a period of change after the extinction. Mammals became more important members of land ecosystems. Birds filled many roles once occupied by other animals. Forests slowly recovered as surviving plants produced new growth. Seeds that had remained buried in the soil were able to grow when conditions became favorable again. During the early Paleogene period, Antarctica still had forests filled with broadleaf trees, conifers, ferns, and flowering plants. Fossils show that many animals continued living there, including early mammals, birds, insects, and freshwater creatures. The climate remained much warmer than today, although gradual cooling had already begun. As millions of years passed, Antarctica slowly drifted farther towards its present position over the South Pole. The continent also became separated from Australia and South America through the movement of tectonic plates. These separations allowed a powerful ocean current to develop around Antarctica. This current reduced the amount of warm water reaching the continent. The climate gradually became colder. Forests slowly declined as temperatures continued to fall. Plant species that depended on warm conditions disappeared from Antarctica. Animals that relied on those forests also vanished. These changes did not happen during a single mass extinction. Instead, they occurred over millions of years as the continent became increasingly isolated and covered with expanding ice sheets. The development of permanent ice transformed Antarctica completely. Forests disappeared, rivers changed, wetlands became buried beneath ice. Many land animals no longer had suitable places to live. Marine ecosystems also changed, as sea ice became an important feature of the environment. Although these later changes were not one of the 5 great mass extinctions, they still caused major losses of Antarctic biodiversity. Species that had lived on the continent for millions of years either disappeared locally or became extinct entirely. New organisms adapted to cold conditions eventually replaced many of the earlier forms of life. Scientists study Antarctic rocks to understand these ancient events because the continent preserves evidence from many different geological periods. Fossils of leaves show damage caused by ancient insects. Fossil wood reveals how forests once grew under long periods of daylight and darkness. Fossil pollen helps identify plant communities that existed before and after extinction events. Bones of dinosaurs, mammals, amphibians and reptiles provide information about changing animal populations. Marine fossils found in sedimentary rocks reveal how ocean ecosystems responded to environmental change. Chemical studies of rocks also provide important clues. Scientists examine tiny amounts of different elements preserved in sediments. These chemical signals help identify periods when oxygen levels changed, volcanic activity increased, or temperatures shifted. Layers of volcanic ash can sometimes be linked to known eruptions elsewhere in the world. These methods allow researchers to connect Antarctic evidence with global extinction events. Modern technology continues to improve the study of Antarctica's ancient past. Satellites help identify rock formations exposed through the ice. Aircraft equipped with special instruments map hidden landscapes beneath ice sheets. Carefully planned field expeditions collect fossils during the short Antarctic summer. Laboratories use advanced equipment to determine the age of rocks and fossils with increasing accuracy. Every new fossil discovered in Antarctica adds another piece to the history of life on the continent. Some fossils represent species already known from other parts of Gondwana. Others belong to species found nowhere else. Together they show that Antarctica supported rich ecosystems for hundreds of millions of years before becoming the frozen continent known today. The history preserved in Antarctic rocks shows that life repeatedly faced severe environmental challenges. Ice ages, volcanic activity, changing climates, altered sea levels, shifting continents, changing ocean chemistry and asteroid impacts all influenced the plants and animals that lived there. Different groups disappeared while others survived and spread into newly available habitats. Each extinction changed the kinds of life that could exist across Antarctica and shaped the long biological history recorded beneath its ice and exposed rocky landscapes. Antarctica did not always sit at the southern end of Earth, where it is covered by thick ice and surrounded by freezing seas. Long before the frozen land became known as the coldest continent, it was part of a much larger landmass that stretched across many parts of the world. The position of Antarctica changed very slowly over an extremely long time because the outer shell of Earth is broken into huge pieces called tectonic plates. These plates are always moving, even though the movement is so slow that people cannot notice it during a lifetime. Over millions of years, these slow movements carried entire continents across the surface of the planet. Antarctica's long trip toward the South Pole happened because of these steady movements deep within Earth. The surface of Earth is made of solid rock, but beneath this outer layer is a hotter part of the planet that can slowly flow over long periods of time. Heat from deep inside Earth causes material in this layer to move. These slow movements help push and pull the tectonic plates resting above them. Scientists study these movements through many kinds of evidence, including rocks, mountains, fossils, earthquakes, volcanoes, and the shape of the ocean floor. Together, this evidence shows that Earth's continents have never stayed in one place for all of Earth's history. The idea that continents move across Earth's surface was not accepted immediately. Many years ago, some scientists noticed that the edges of several continents seemed to fit together. South America and Africa appeared to match each other like pieces that had once been connected. They also found fossils of the same ancient plants and animals on continents that are now separated by wide oceans. Rocks of the same age and mountain ranges also appeared on different continents. These discoveries suggested that the continents had once formed a single large landmass before breaking apart. As more evidence was collected, scientists developed the modern theory of plate tectonics, which explains how Earth's surface changes over time. Antarctica was once part of an ancient supercontinent called Gondwana. This enormous landmass included what are now Antarctica, Africa, South America, Australia, the Indian subcontinent, and several smaller land areas. During this period, Antarctica was located much farther north than it is today. The climate across much of the continent was much warmer than the climate found there today. Forests grew across large areas, rivers flowed through valleys, and many different kinds of plants and animals lived on the land. The rocks found in Antarctica provide important evidence of this ancient past. Scientists have discovered fossil leaves, tree trunks, roots, pollen, seeds, and many other remains of plants that could only have lived in much warmer conditions. Fossils of dinosaurs, early mammals, amphibians, insects, and birds have also been found in Antarctic rocks. These discoveries show that Antarctica once supported rich ecosystems over a very long period. Such life could not have survived under the thick ice that covers most of the continent today. As Gondwana existed, the tectonic plate carrying Antarctica slowly moved across Earth's surface. The movement was extremely slow, usually only a few centimeters each year. Although this speed seems very small, the movement continued without stopping over millions of years. Even such tiny yearly changes added up to enormous distances across geological time. Deep beneath the surface, rising heat caused hot rock to move upward, while cooler rock slowly sank downward. These slow movements inside Earth helped create forces that acted on the tectonic plates. New ocean crust formed where molten rock rose through cracks on the ocean floor. As fresh rock cooled and hardened, it slowly pushed older crust away. At other places, older ocean crust sank back into Earth's interior. These ongoing processes kept Earth's surface changing throughout its history. The first major stages of Gondwana, breaking apart, happened as deep cracks formed within the giant landmass. These cracks slowly widened over millions of years. Magma rose from below and filled many of these openings. As the crust stretched farther apart, new ocean basins slowly formed between the separating pieces of land. The growing oceans gradually divided Gondwana into smaller continents. Africa began to move away from Antarctica. South America also slowly separated as new ocean crust formed between them. These changes did not happen suddenly. They took place over many millions of years. The land slowly pulled apart while seawater entered the widening gaps. New coastlines formed as the oceans expanded. The Indian subcontinent also separated from Antarctica. After breaking away, it moved northward across the ocean at a relatively fast speed for a tectonic plate. This long movement eventually led to its meeting with Asia, where large mountain ranges later formed because of the continuing collision between the plates. Australia remained connected to Antarctica for a much longer time. The two continents shared many plants and animals because land still linked them together. Rivers crossed the connected landscape and forests covered wide areas. Over time, new cracks developed between Australia and Antarctica. The land slowly stretched apart until seawater entered the growing gap. A new ocean formed between the two continents as they continued drifting in different directions. The gradual separation between Antarctica and Australia marked an important stage in Antarctica's journey toward its present position. As Australia moved northward, Antarctica continued drifting farther south. The growing distance between the continents allowed ocean water to flow more freely around Antarctica. These changes in ocean circulation later became an important part of the continent's changing climate. South America also remained connected to Antarctica for a long period after other parts of Gondwana had already separated. Eventually, this final land connection also broke apart. The opening between South America and Antarctica created another important passage for ocean water. Once this opening became wide enough, water could move almost completely around Antarctica without being blocked by large land areas. This continuous flow of ocean water around Antarctica became known as the Antarctic Circumpolar Current. It carries enormous amounts of water around the continent. The current helps separate Antarctica from warmer ocean waters farther north. As less warmth reached the continent, temperatures gradually became lower over very long periods. Snow that fell during winter survived longer, and more ice slowly built up year after year. The movement of Antarctica toward the South Pole also changed how much sunlight reached the continent during different seasons. Near the South Pole, the yearly pattern of daylight is very different from places closer to the equator. During part of the year, the sun remains above the horizon for many weeks. During another part of the year, the sun stays below the horizon for many weeks. These long periods of darkness reduce the amount of heat reaching the surface during winter. Over long periods, these seasonal patterns helped support the growth of permanent ice. The first large ice sheets did not appear immediately after Antarctica moved southward. The process took a very long time. Earth's climate also changed because of many natural causes, including changes in the amount of carbon dioxide in the atmosphere, changes in ocean circulation, and changes in Earth's orbit around the Sun. As these different factors worked together, conditions slowly became favorable for large ice sheets to grow across Antarctica. Once thick ice began to spread across the continent, it reflected much of the sunlight that reached its surface. Less solar energy was absorbed by the ground beneath the ice. Cold conditions became more common across larger parts of Antarctica. Glaciers slowly expanded across mountains and valleys. Many ancient forests, rivers, and landscapes disappeared beneath growing layers of snow and ice. Although Antarctica became covered by ice, the continent itself continued moving with its tectonic plate. The movement never stopped. Even today, Antarctica is still part of a moving tectonic plate. Modern satellites can measure this movement with great accuracy. Scientists can detect shifts that are only a few centimeters each year. These careful measurements confirm that Earth's plates remain active today. The rocks beneath Antarctica preserve valuable information about every stage of this long journey. Some rocks formed deep inside ancient mountains. Others formed on riverbeds, floodplains, deserts, forests, beaches, or shallow seas. Each layer records the conditions that existed when it was created. By studying these layers, scientists can rebuild the history of Antarctica's movement across Earth's surface. Magnetic minerals inside volcanic rocks provide another important source of evidence. When molten rock cools, tiny magnetic minerals line up with Earth's magnetic field at that time. Once the rock becomes solid, the minerals remain locked in place. Scientists can measure their direction and use the information to estimate where the rock formed in relation to Earth's magnetic poles. Rocks from Antarctica show that the continent occupied different positions during the different periods of Earth's history. The growth of glaciers and the birth of the frozen continent happened over a very long period of Earth's history. Antarctica was not always covered by thick ice. Long before the continent became frozen, it had rivers, forests, lakes, mountains, and many kinds of plants and animals. The land experienced warm weather for millions of years. The changes that turned this green land into the coldest place on Earth happened slowly. They were caused by changes in the movement of the continents, the position of Antarctica on the planet, changes in the atmosphere, changes in the oceans, and changes in the amount of heat reaching different parts of the Earth. During the early part of Antarctica's history, the continent was joined with other large land areas as part of the ancient supercontinent called Gondwana. Antarctica was connected to South America, Africa, Australia, the Indian subcontinent, and other pieces of land. Because these lands were joined together, warm ocean water could move differently from the way it does today. Warm air and moisture also spread across the connected land. Many areas that are now frozen had weather that allowed forests to grow. Large trees covered much of the land. Ferns, mosses, seed plants, and many other kinds of vegetation lived across the continent. Fossils found in Antarctica show that these plants once grew in places that are now buried under thick ice. Animals also lived in Antarctica during this time. Dinosaurs walked across the land during the age of dinosaurs. Smaller reptiles, insects, fish, and early mammals also lived there. Rivers carried fresh water through valleys, and lakes formed in low areas. The soil supported many kinds of plant life because temperatures were much higher than they are today. Although Antarctica already experienced long periods of daylight and darkness, because of its southern location, the climate was still mild enough to support rich living environments. The movement of Earth's tectonic plates slowly changed the position of Antarctica over millions of years. The continent gradually drifted farther south. This movement happened at a very slow speed that could not be noticed during a human lifetime. As Antarctica moved closer to the South Pole, it received less direct sunlight during the year. The lower angle of sunlight meant that less heat reached the surface. Summers became cooler and winters remained cold for longer periods. These changes did not immediately create a continent covered in ice, but they marked the beginning of a slow cooling process. The atmosphere also changed during this long period. Carbon dioxide is one of the gases that helps keep Earth's surface warm by trapping heat. During different parts of Earth's history, the amount of carbon dioxide in the atmosphere changed because of volcanic activity, weathering of rocks, the growth of plants, and the movement of carbon through the oceans. As the amount of carbon dioxide gradually became lower, less heat remained in the atmosphere. This allowed temperatures to fall across many parts of the planet, including Antarctica. Changes in the oceans also played an important part in the cooling of Antarctica. While the continents slowly moved apart, Antarctica became separated from South America and Australia. This created wide ocean passages around the continent. One of the most important events was the opening of the passage between Antarctica and South America. Another important change happened between Antarctica and Australia. These openings allowed ocean water to move freely around Antarctica. As water began flowing around the continent without being blocked by connected land, a powerful ocean current developed. This current moved from west to east around Antarctica. It carried cold water around the continent and reduced the amount of warm water reaching the Antarctic coast. This helped keep the surrounding seas cold throughout the year. Cold ocean water also cooled the air above it. The cooler air made it easier for snow to remain on the ground instead of melting during the warmer months. Snow is an important part of glacier growth. In places where more snow falls during winter than melts during summer, the snow begins to build up year after year. Fresh snow is light and contains a great deal of air. As more snow falls on top, the lower layers become heavier because of the weight above them. The snow crystals are pressed together. The spaces filled with air become smaller. Over many years, the snow changes into dense ice. This process is slow and continues as long as new snow keeps falling. The first glaciers in Antarctica were much smaller than the huge ice sheets seen today. They likely formed on high mountains where temperatures were lower than in nearby valleys. Snow remained on these mountaintops throughout the year. As layer after layer collected, the snow slowly turned into ice. The growing ice became heavy enough to move downhill under its own weight. This movement marked the beginning of glaciers spreading across the landscape. Glaciers move very slowly. The ice does not remain completely still. The enormous weight causes the lower parts of the glacier to bend and flow. Gravity pulls the ice toward lower ground. Some glaciers move only a short distance each year, while others travel farther depending on the shape of the land, the amount of snowfall, and the temperature. Even though the movement is slow, glaciers can travel across great distances over thousands of years. As glaciers advanced across Antarctica, they covered valleys, rivers, forests, and rocky ground. Trees that once stood in the open became buried beneath growing layers of ice and sediment. Lakes disappeared beneath thick ice. River systems stopped flowing across the surface in many areas because the ice covered their paths. The weight of the growing glaciers also changed the shape of the land beneath them. Ice is extremely heavy. When glaciers become several miles thick, they press down on the rocks below. The land surface slowly sinks under this great weight. This process happens over very long periods. The Earth's crust responds slowly because it rests on softer material deeper inside the planet. As glaciers continued growing, much of Antarctica's surface was pushed lower by the weight of the ice above it. Glaciers also changed the landscape through erosion. As ice moved across the ground, it carried rocks, sand, and broken pieces of stone. These materials scraped against the surface beneath the glacier. Over thousands and millions of years, valleys became wider, hills became smoother, and loose material was carried from one place to another. Rocks were broken into smaller pieces by the force of moving ice and changing temperatures. Some of this material was left behind when glaciers slowed or changed direction. Not every part of Antarctica became covered by ice at the same time. Some regions remained free of permanent ice longer than others. Lower areas close to the sea may have continued supporting small amounts of plant life for some time after mountain glaciers had already formed. As temperatures continued falling, glaciers spread farther across the continent. Ice eventually joined together across large areas, creating an expanding ice sheet.